This is the introduction to the conservation of energy with an Atwood machine. An Atwood machine is just a pulley with weights on each side. For example, you think, well, that's kind of a silly thing. Everybody that's ever ridden in an elevator, you've ridden in an Atwood machine. Because what they found out when they first invented the elevators, that if you put a bunch of people in, let's say this is your elevator, you put a couple thousand pounds in there and you're going to have your motor just pull it up with no weight on the other side. The motor had to be so big that the roof of the building couldn't support it. Then they found that if they put some other weight on the other side of the pulley, say about half the expected weight, then the motor could either have to pull this weight up or pull this weight up, but it didn't have to work nearly as hard. And the lab today will show you why. If you stop and think about it, if these two weights are equal, you can easily move them. So by putting a weight on one side, it makes it much easier to lift the other weight. Another example that's in this room. Inside this board right here, there's a pulley system. Now before we added the whiteboard and it was a chalkboard, it was pretty easy to lift this board up. Now it's not because I've added more weight. But the way they made it easy to lift up was they had some weights inside the board here that counterbalanced the weight of the chalkboard. Now if I was really worried about it, I could make it easy to pull up again by adding some more weight in here. But that's what an Atwood machine is. We're going to do two things with this Atwood machine. We're going to look at its efficiency. We're going to do one that will be very efficient because we've got smart pulleys with very little friction, and we're going to look at the acceleration of the Atwood machine. Now, the lower the acceleration, if we have a lot of weight here but don't have a lot of acceleration, that would tell us it wouldn't take us much force to move it, which is the whole purpose of the Atwood machine. So our basic setup is that M1 will be more than M2. It will be a certain height above the floor, which you will measure. The initial velocity obviously will be 0. Then you're going to let go. Then M1 will go all the way to the floor. M2 will rise the same height that M1 dropped. So you don't have to measure both times. You know it's going to go up as far as this one went down. So what we're going to, energy that's going into the system is the loss of potential energy of M1. So that would be M2G delta H. That's how much energy we put in the system. We get two things out. We raise M2, so we've gained some of potential energy here. And we've also got speed. If you measure the velocity right before it hits and stops, that energy that went into the system turned into kinetic energy. Now that's the kinetic energy of both these together because they're both moving. It's one system. So our output's going to be our kinetic energy and the change in potential energy that we gained, and our input's going to be the potential energy we lost. And you'll see more details of how we calculate this in a later video when I go over the notebook. But this is the introduction to what we're going to do. Good luck.